Hi guys, you're welcome to God Academy. In this lesson, I'll be taking you through non-exact differential equations and homogeneous differential equations. In our differential equation course, I've taken you through from classification of differential equation through to all the different types of first order differential equations. This is the last set which we are doing in this round. If this is the first time you are visiting this channel, kindly subscribe and please visit the old videos so that you understand the focus. Non-exact differential equations. In our previous lesson, I took you through exact differential equation. You got to know that for every exact differential equation, it has the form m function of xy x plus n a function of xy dy is equal to 0. This is the general or standard form for every exact differential equation. I showed you that you have to text for exactness that m x y should be equal to nyx. That is, you are going to take the derivative of the m function, which is from the partial derivative with respect to x. You differentiate that one with respect to y, and the same opposite here. The two derivatives should be equal, and that will test for exactness. Now, there are situations where you have an equation which will follow this same standard. But once you find your mxy and your nyx is not the same, therefore they are non-exact. How do you solve that, or how do you go about that? That is what I'm going to show you in this video. Stay glued to your seat and watch to the end. So if you find your exactness test and find out that your differential equation is non-exact, now the solution is we have to make it exact. Okay, so we will have to make it exact. So make it exact. That is the whole goal. You will make it exact. How do I make a differential equation which is not an exact differential equation into an exact differential equation? So to do that, I'll simply introduce what we call integrating factor, mu of x. Integrating factor. So integrating factor here that we have will be the factor we will multiply through our equation to convert our equation from non-exact differential equation to an exact differential equation. So let's see. If I have the mx, which is the partial derivative with respect to x part plus our ny. Sorry, no, I won't say plus. Let me clean the plus. So let me show you this. So mx, and you also have ny. Okay, these two are the partial derivatives with respect to x and y, and we get it from here and here. Okay, that is what we use for our test. Okay, so mx here, as I said, differential equation is simply having a function and differentiating. So when it contains derivatives, we call it differential equation. Our goal is to reverse it back to the function. Exact differential equation arises from what we call implicit functions. Okay, so these types of function has both x part, y part, sometimes it can be three parts. Okay, we call them multi-dimensional functions. That is, the dependency is on more than one variable. Okay, so now let's see something here. In your test, if you find mx and ny, and we have the integrating factor to be equal to mx minus ny over n is equal to f of x. That is one. Or ny minus mx over m is also equal to f of y. And this is 2. So our integrating factor is simply mu of x, which is equal to which is equal to e to the power integral of f of x, or mu of x is equal to e to the power integral of f of y. Let me explain this. You know that when you want to test for exactness, you always differentiate this with respect to y and this with respect to x. If they are not equal and you want to convert it to exact, then it means that we are going to make use of these two derivatives we found. I will subtract my mx from my mn and I'll divide it by n. I'm supposed to get a function of x, okay? And when I take e to the power integral of that function, I get the integrating factor. Or I can subtract my m of x rather from n and divide it by m, and I'll get a function of y. So my integrating factor then becomes e to the power integral of f of y. Okay. Now, you can go by any of these, but sometimes the function may be very complicated. So we go by the easiest approach. Okay. Once you find your integrating factor, you multiply through. So you have your integrating factor mu of x or mu of y, multiplying m xy dy. Oh, sorry, the x plus mu of x multiplying n of xy dy equals 0. That is what we are going to do. Let's solve an example so you understand it better. For example 1, have t dx over dt plus t minus x is equal to. This is the problem you have at hand. You have to solve it here. Now, I told you that whenever you want to solve an exact differential equation, the first step is for you to get rid of this decompose. So I'll simply have t dx plus t minus x equal to 0. Once I decompose this, then my test comes. So I have told you that whatever function attached to the dx, you differentiate it with respect to the y. But now you are not using y, but you're using, so you differentiate this with respect to t. And this is attached to the t, you differentiate with respect to x to test for exactness. Okay. So here, when I come here, what do I get? Differentiating this with respect to t, I get to 1. So I'll say that my m of t is equal to what? Sorry, not m of t. Let me make it m of x. So my mx is equal to t. So when I differentiate, I get 1. Then when I come to my ny, I'm just using mx and my because of the illustration I showed you here. So the y and the x, forget about that. Here, it's attached to the t. So I rather differentiate it with respect to x. Differentiating this expression with respect to x, you realize that t is a constant, so it's 0. X here is negative x. When I differentiate, I get negative 1. And you can see 1 and negative 1 are not the same. Therefore, this is not exact. Or we say that it is non-exact. If it is non-exact, then how do you make it exact? So let's see something. As I told you, the integrating factor, there are two ways. Either I subtract mx and y over n. So that would be the first approach would be mx minus ny over n. And this will give me 1 minus minus over my n, which is t minus x. Is that not it? This gives me 2 over t minus x. And the integrating factor mu of x will simply be equal to e to the power integral of 2 over t minus x. Let's check the other way around. The other way around will be ny minus mx over n. And that will give us negative 1 minus 1 over t. This gives me negative 2 over t. Then mu of t, right? Simply equal to e to the power integral of negative over t. You can see that 2 over t minus x and negative 2 over t. This is far simpler to go by. So why don't you forget this? And that is why there are two ways. Choose the simpler approach all the time. Okay. So now our integrating factor, whether mu of t or mu of x, I'm just using x. Okay. Now let's simplify this expression. You get that you put your negative 2 out. I have negative integral of 1 over t. Then this gives me integral negative 2. Integral of 1 over t is, therefore, we are going to have e to the power, the negative 2 will be on top, so ln to the power negative. E to the power ln goes away and our answer becomes t to the power negative, or you can say 1 over t, right? Then once I get 1 over t squared, I'll multiply through my differential equation back again. So multiply your integrating factor throughout again. So I'll have t dx over dt, right? Multiplying 1 over t squared plus t minus x multiplying 1 over t squared is equal to 0. So now let's simplify back again. When I simplify this expression, t will cancel 1 t, so I'll have 1 over t dx over dt plus here I'll decompose it. So I'll have t over t squared. That will give me 1 over t. And I'll have negative x over t squared equal to 0. Let me put bracket. Therefore, decomposing, I'll have 1 over t dx plus into bracket 1 over t minus x over t squared dt is equal to 0. So with this expression here, I have a differential equation which is an exact once again. Let's check whether now it is indeed exact. We have changed it from non-exact to exact. Let's see. To do that, I will differentiate this with respect to t because it's attached to the x. When I differentiate this with respect to t, what am I getting? I'm getting this is negative t to the power negative 1, right? So I'll get negative 1 over t squared. Go and revise your differentiation. When I differentiate this with respect to x because it is attached to the t, 1 over 2 will be 0. When I differentiate here, negative x, it will give me negative 1 over t squared. But negative x will give me 1, and this one is a constant. Therefore, they are now exact. Powerful. We are done. Now we have converted our equation to exact. So what do? We use the approach. I'll take 1 over t dx and I'll integrate this separately. What am I getting? I'll get ln t plus c. I'll take the other one, integral 1 over t minus x over t squared. All the t is equal to 0, right? Oh, sorry, I made a mistake here. Oh. Good. But I found it earlier. See, this one is attached to the x, so integral 1 over t dx. We are integrating with respect to x, not t. So the answer, t becomes a constant. So we have 1 over t integral dx. And this gives me what? X over t plus c. We put it down. Then we integrate this side too. So integral of 1 over t minus x over t squared. We are integrating this with respect to the t. Okay. With respect to the t, what are we getting? This becomes what? Ln t. And this becomes, x becomes a constant. Okay. We are going to get negative x outside. When I differentiate negative 1 over t squared, this is the same as t to the power negative 2. So when I integrate, I'll just add 1 to it. I'll have t to the power negative 2 plus 1 over negative 2 plus 1. This is t to the power negative 1 over negative 1. So negative 1 over t, okay. So I have over, so negative x. Now already x is negative 1, which I pushed outside. So I'll simply have, so I use negative 1 out of t2 to do this expression. So it still becomes negative x over what? T, right? So now this is what we have here. This is what we have here. I want to confirm this very well here so that no, here will rather become positive because you have negative x, and when you differentiate 1 over t squared 2, it becomes negative. So you get positive. When you integrate, sorry, become positive. At this point, we have plus c. Then the next thing is we call it merging. We are going to merge it. Okay. We are trying to merge this and this. That it becomes one. So our solution to our differential equation xy is simply equal to, when I come here, I'll ask myself x over t. We take only one of them. X over t plus I have ln t here, then plus c. And that is my answer. Differential equation. And that is all for non-exact differential equation. We're solving plenty questions along the way. Now let's send you to the different method which we call homogeneous. Homogeneous differential equation. Homogeneous differential equation. So for homogeneous differential equations, what we are trying to do is we use a general method called substitution. General method called substitution. So substitution method is a method where you try to change some expressions within your differential equation with a particular variable so that we can convert it from one form to the other. Okay, so now let's see something. Let me straight away give you a problem. So this is our problem for substitution method. So I have y prime plus 4x squared plus y squared equals 0. Now take note, for every substitution method, you should expect an expression y over x. Then you make this the subject to v. Okay. So always make sure you have an expression like this before you can say that it's homogeneous for the first order. Okay. Take note of that. So how do we make expression y over x out of this? I can see xy attached to y prime. For me to get y prime free, meaning that I have to get rid of this xy. Is that not it? So now what do I do? My goal is to get expression like y over x, where it is squared, you divide through by what? X squared. Okay, so now let's see something here. First of all, I'll divide through by x squared. Since I have x squared and I have y squared and I want to get y over x. Dividing through by x squared, what do I get? S squared, s squared, s squared, then s squared. This x cancel one of this x, so I'll be left with what? Y over x, y prime. Okay, plus this cancels this at all. I'll get 4 plus y over x all squared equals 0. You can see clearly I've just made a substitution y over x. I'm sorry, I've converted this to y over x. And at this point, I'll say v is equal to y over x. Wherever you see v, wherever you see y over x, you put v there. As simple as that. Okay, but wait, there's one interesting thing here. Before you make substitution for v, you always simplify this expression as y is equal to vx. So when I cross multiply y equals vx, right? For us to successfully make all substitution, I have to get rid of every y x and change everything to v. For that reason, this y prime must also go. How do we get rid of y prime? We can make some derivatives here, then that can replace that. So differentiating this, I get y prime is equal to, this is a product rule. So I have v prime x plus what? V. So here is when I differentiated v and remain x. Now I remain v and differentiated x and became 1. This is the substitution you're going to make. Wherever you see y over x, you put what? You put v there. Wherever you see y prime, you put v prime x plus v. As simple as that. So here I'll get what? Let's do a substitution. I'll get v for this. Y prime now becomes v prime x plus v. As simple as that. Plus 4 plus this is also v squared is equal to 0. At this point, you do separate of variables. You can see v and x, and I think separable will be the easiest way to solve this, right? Because there's only one x, the rest are v. I can separate it easily. I'll move the v's to the other side. Okay, so I'll have v multiplying v prime x plus v is equal to negative 4 minus v squared. At this point, I'll have v prime x plus v is equal to negative 4 minus v squared all over v. Is that not it? At this point, I'm still not done. I have to make v the subject. So v prime x is equal to negative 4 minus v squared over v minus v. That's still not done. Let's simplify this expression. So we're going to have negative 4 minus v squared minus v squared over v. Should be giving us v prime x. At this point, I simply get negative 4 minus 2v squared all over v is equal to v prime x. Okay, so once I have done this, you can clearly see that. Let me convert this for you to see. So this is same as dv over dx. Okay, so I have negative 4 minus 2v squared over v is equal to dv over dx. Then I have what? X here. How do I successfully separate variables? We have we have in separation of variables, your dv should be attached to the v side and dx should be attached to x. But now dx is down. I need to change variables, cross it. Okay, so every v will come to the right side and every x will go here. So doing that, I'll have my the x over x is equal to, everything here will go in the opposite way. I'll have v all over negative 4 minus 2 squared v. This is what I did. I cross multiplied and I divide. I cross multiplied and I divide. That is the simple way to drag it. Okay. Once I've done this, you can clearly see that I've separated variables. So I integrate both sides. Integral of 1 over x dx should be equal to integral of v over negative 4 minus 2v squared dv. On my left side is simple, len x plus c. On my right side, that is where the problem comes. How do I integrate this? I'll make this using substitution. Let u be equal to negative 4 minus 2 squared. So du over dv give me what? This is 0. That will give me negative 4v, right? Now I can make um dv the subject, okay? Wherever I see dv, I'll change it. So therefore, or I can make, yes, let me make dv the subject. So dv is simply equal to 1 over negative 1 over 4v. Therefore, I'll come and change the subject here. So integral v, right? This v here over this now is no more this but u. So I've represented everything with, so I have u. Then dv here is equal to what? Negative 1 over 4v du, right? So this v simply cancel this, and I'm simply going to have integral of 1 over u times negative 1 over 4 u, which then eventually gives me negative 1 over 4 outside, 1 over u. So integral of 1 over u is simply len u, right? So negative 1 over 4 len u plus c. Now, we are not interested in u, so let's come back to our answer. So here becomes len x plus c is equal to negative 1 over 4 len, now not u, but u is what? Negative 4 minus 2v squared plus c. So we choose only one c, so I'll clean this c and we are done. So len x is equal to this plus this, and that's the answer. So thank you for being with me in this class for homogeneous and non-exact. I hope seeing you for higher order differential equation. Until then, subscribe and bye bye.